Well, hello everyone. Today's notes are on double angle formulas and some other things that we'll see later, but this is section 5-5 in your textbook. And the double angle formulas are given on your note sheet. These are not them. Do not write these down. You already know these. These are the sum and difference formulas, but I want to show you where the double angle formulas come from. So we know from some work we previously did that the sine of u plus or minus v equals all of this. What if we just did this? What if we try to find the sine of u plus u? So that means we're using the top sign here. We're just going to use u throughout here. So that'll give us the sine of u times the cosine of u plus the cosine of u times the sine of u. And since these two are the same, we can say that equals 2 times the sine of u times the cosine of u. And adding u plus u, that's like saying, hey, that's a sine of 2u. So if you want to find the sine of double an angle, here's the formula that you can use. And we can do the same for cosine and for tangent, but what we'll get is what's called these double angle formulas. And the double angle formulas are on your note sheet. Here's what they are. Now one thing just to warn you about, see the cosine formula, cosine of 2u? There's actually 3 different expressions that that's equivalent to. If you do the same process I just did, you'll get this first expression. But then if you do some substitutions with Pythagorean identities, you might get the second or the third expression. Now sometimes one of these is preferred over the others. Now I actually prefer to use these last two because then you only have one trig expression to worry about, either sine or cosine. But just realize that, hey, cosine of 2u or cosine of 2 times any angle, you can choose to use any of these 3 expressions for that. Okay, now first kind of problems go back to something we did a couple units ago here. We need to solve this equation. Now what's impossible with what we know so far, what makes this impossible is that we have the cosine of x and the sine of 2x. That makes this impossible. However, now we know we can do a substitution because the sine of 2x we just found out is equal to 2 times the sine of x times the cosine of x. And I'll bring everything else down. So if we make that substitution, now everything's written in terms of x. So now we can factor here. I'm going to pull 2 times the cosine of x out of both of these terms, which gives me 1 plus the sine of x. And let's set both of these parts equal to 0. So I can say 2 times the cosine of x equals 0, and I can also say 1 plus the sine of x equals 0. So this means the cosine of x equals 0, which if you look on your unit circle, that happens in 2 places. That happens at pi over, actually is that 2 places? Let's see here, pi over 2 and 3 pi over 2. Here if we subtract 1 from both sides, I get the sine of x equals -1, which happens in 1 place, which is 3 pi over 2. We already have that answer, so here's our 2 solutions. X could be either of these angles. Okay, so all the steps from here on down we've done before. The only thing new was that substitution. Okay, so if you ever have one of these equations where you have an x and a 2x, look to make a substitution. Let's look at one more kind of like that. So we have cosine of 2x plus cosine of x equals 0. So we need to make a substitution. Now we have a few different choices here. We could plug in here cosine squared of x minus sine squared of x. But think about that. Then we'd be involving cosine and sine. We could plug in here 1 minus 2 sine squared of x, but then we'd have sine and cosine. Let's substitute 2 times the cosine squared of x minus 1. And then we'll bring everything else down. And the reason I chose that one is because now we have this equation with just cosine. I'm going to, let's see here, let's try to move things around a little bit. 2 times the cosine squared of x plus the cosine of x minus 1 equals 0. And this goes back to an algebra 2 type problem. So if we have 2y squared plus y minus 1 equals 0, we would factor. And we'd factor this as 2y minus 1 times y plus 1, and then solve both of these, and we know how to do it from there. Let's try to factor what's on the left the same way. That's going to give us 2 cosine of x minus 1 times the cosine of x plus 1 equals 0. And once this is factored, we can set both parts equal to 0 and then solve for cosine of x. Do the same thing over here. So looking on our unit circle, we get x could be, from this first equation here, x could be pi over 3. It could also be 5 pi over 3. And from the second equation, we get x could be pi. So we have 3 possible solutions to this equation. Okay, so there's one use of these double angle formulas. Let's get into another use. Okay, so in this case, we don't know what theta is equal to. We don't know what the angle is equal to. So what we'll probably have to do here is make a sketch of this angle. Now it tells us the angle is between 3 pi over 2 and 2 pi, which means it's in quadrant 4. So I'm going to sketch this angle over here in quadrant 4. It's going to look something like this. So theta is really this entire angle all the way around. And the cosine of that angle is 5 over 13. And using the Pythagorean theorem, we can see that this missing side is negative 12. Now we're saying, what if we double that angle? So here's that angle measure. What if you double it? What would be the sine of that new angle, the cosine of that new angle, and the tangent of that new angle? Okay, well, I'm going to use those double angle formulas to help me out with this. We know that sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. And we can pull all these values off that diagram on the right-hand side. So this is equal to 2 times negative 12 thirteenths times 5 thirteenths. Now don't try to distribute or anything. We can just do the top times the top and the bottom times the bottom, which if we do that, we get negative 120 over 169. So if we double this angle, our new angle would have a sine of negative 120 over 169. What about the cosine? So again, we can pick any of those double angle formulas. I'm going to just use the first one that says the cosine squared of theta minus the sine squared of theta. So cosine is 5 thirteenths. We want to square that. Minus sine is negative 12 thirteenths. We want to square that, which is equal to 25 over 169 minus 144 over 169, which is equal to, if I subtract those, I get negative 119 over 169. All right, last one up here, tangent. Now, tangent's the easiest of these because, hey, tangent of any angle is equal to the sine over the cosine. And if we wrote this sine over the cosine, they both are over 169. So really, those 169s would simplify. So I can jump right to my answer here. The tangent would be negative over negative, so positive 120 over 119. So if we double that angle, the tangent of that new angle would be 120 over 119. Okay, let's try one more just like that. So again, we know our first step is to sketch this. It tells me that u is between 0 and pi over 2, which means quadrant 1. So here's angle u. The sine of u is 3/5. Pythagorean theorem tells me that our missing side is 4. Okay, now I have the sine of 2u, which our formula tells me is 2 times the sine of u times the cosine of u, which is 2 times 3/5 times 4/5. Think of 2 as 2 over 1 and say top times the top and bottom times the bottom. That's 24 over 25. Cosine of 2u. Well, that's going to be equal to the cosine squared of u minus the sine squared of u. So cosine of u is 4/5. We'll square that. Minus sine squared of u is 3/5, and we'll square that. So that gives me 16/25 minus 9/25, which is equal to 7/25. Last but not least, the tangent of 2u. This is the easy one because it's equivalent to sine over cosine, which is 24 over 7. All right, so there's some uses of our double angle formulas. Now, at the beginning, I said that something different would be coming later, so I'm just going to write this double angle formula for cosine. So the cosine of 2u equals any of these expressions. And I'm just going to look at this one right here. So if we say the cosine of 2u equals 2 times the cosine squared of u minus 1. And if I add 1 to both sides here, and then divide both sides by 2, I get the cosine of 2u plus 1 all over 2 equals the cosine squared of u. Now this is what's called a power reducing formula. And if I would have set up my original equation using one of these others, I could have done the same for sine squared or even tangent squared. But it's called a power reducing formula. And here's all the power reducing formulas. Now, I'll be honest with you, these are on your note sheet, but these are not that useful. They're not very useful formulas. However, they do give us something that is useful. So I'm going to look at this one right here, at this power reducing formula. And let's see here. What if we were to take the square root of both sides of this? That would give me the cosine of u equals plus or minus the square root of 1 plus the cosine of 2u over 2. And if we take u and divide it in half, we could say the cosine of u over 2 equals plus or minus the square root of 1 plus the cosine of u over 2. Now this is a much more useful formula. The power reducing formula is not very useful. This is what's called a half angle formula. And we could solve for sine, cosine, or tangent. Any of those we solve for, we get these half angle formulas. These again are on your note sheet. Half angle formulas for sine of an angle divided by 2, cosine, or tangent are given here. Now we can't have two possible answers. So like this would be like saying if we were looking for the sine of 15 degrees. Sine of 15 degrees isn't going to be both a positive and a negative quantity. So we have to think about where our angle is at and what our sine of that angle would be. Would it be positive or would it be negative? Okay, so let's look at a couple examples using this. So if we want to find the sine of 105 degrees, now 105 degrees is not on your unit circle, but 210 degrees is. So we could find the sine of 210 divided by 2. We're really finding the sine of half of this angle. All right, so that means, let's see here, I'm going to use that half angle formula for sine. Half angle formula for sine is plus or minus the square root of 1 minus the cosine of 210 degrees all over 2, which is going to be plus or minus the square root of 1 minus cosine of 210 degrees is square root of 3 over 2 all over 2. And I'm just going to think of this 1 as 2 over 2 because you can see we need a common denominator there. So this equals plus or minus the square root of 2 minus square root of 3 over 2, then over 2 again. Okay, if we multiply top and bottom here by 2 just to clean things up, we get plus or minus the square root of 2 minus the square root of 3 over 4. All right, so we need to take the square root of both top and bottom of this. So that gives me plus or minus the square root of 2 minus the square root of 3. Square root of 4 is just equal to 2, so I'll just do this. And it is okay to have square roots inside other square roots. Now, this answer here is plus or minus. We can't have two solutions. We got to think about this. 105 degrees, if we were to sketch this, would be right about here. The sine of that angle would go upward here. So this quantity right here would be positive. So our answer is a positive quantity. So here's our answer. The square root of 2 minus the square root of 3 over 2. Careful. Biggest mistake people make is they keep that plus minus in their solution. Really, we can't have a positive and a negative answer. Let's look at one more of these kind of problems. Now, what some people like to do is just take care of that plus minus right away. So this is going to be, again, cosine of 15. 15 isn't on our unit circle, but 30 degrees is. So I can say the cosine of 30 degrees over 2. And if I think about where 15 degrees is, it's right about here. Cosine is going to be positive, so I know that this, even though this formula says plus or minus, which I'll keep to start, it's really going to be a positive quantity in the end. So the formula is 1 plus the cosine of u, which I'll write as 30 degrees, over 2. Which, forget the plus minus, we know it's going to be positive. It's going to be 1 plus the cosine of 30 degrees is square root of 3 over 2. And hey, it's looking very familiar, very similar to the last problem. So I'm going to simplify in the same kind of way. And this is going to be 2 plus the square root of 3 over 4. And we'll take the square root of the whole thing, which equals square root of 2 plus the square root of 3 all over 2. And with these kind of problems, you will get very similar. We actually got the same exact answer for these, but you'll get very similar kind of answers. Okay, so half angle formulas are useful if we're looking for an angle not on the unit circle, like 15 degrees. Even from this, we can now find the sine or cosine of 7.5 degrees. Sometimes we have problems that don't give us angle measures, and I want to run through a couple examples of those. Now, we've seen problems similar to these before. On these similar problems, what we did is we had to make a sketch of this. So I'm going to start by making a sketch of an angle in quadrant 1 that has a cosine of 7 over 25. And using the Pythagorean theorem, we can find the missing side. Now the sine of u over 2, we know that's equal to plus or minus the square root of 1 minus the cosine of u over 2. Now if we cut this angle in half, so if I think about this angle being cut in half here, we know that the sine, cosine, and tangent of that angle will all be positive, so that plus or minus we don't have to worry about at all. Okay, so let's just pull cosine of u off of that diagram there. So that gives us the square root of 1 minus 7/25 over 2, which is equal to, if I think of this as 25 over 25, get a common denominator there, that gives me 18 over 25 over 2. Now multiplying top and bottom here by 25 gives us square root of 18 over 50. If we simplify that, that's the square root of 9 over 25. And that whole thing simplifies to just the answer 3/5. So if we take half of that original angle, the sine of that new angle will be 3/5. Now let's think about that. We could find cosine and tangent using those formulas. Or here's another way to do this. You can think, all right, this new angle here, and I'm going to use a different color here. This new angle has a sine of 3/5. We can fill in the rest using the Pythagorean theorem and say, hey, the cosine must be 4/5, and the tangent must be 3/4. So once we have one answer, we don't have to do all the work necessarily to find the second answer. Sometimes we still do, but not always. Okay, let's go to our last example of our notes. Same kind of problem, and I'm going to start with a sketch of this. Our angle's in quadrant 1. Our sine of this angle is 4/5, and our missing side is right here. We're saying, let's say we cut this angle in half. What would the sine, cosine, and tangent of this new angle be? Well, I'll start with sine. So sine would be plus or minus, and I'm not even going to write the plus minus because I can see sine, cosine, tangent are all going to be positive. So it's going to be the square root of 1 minus the cosine of u over 2, which equals square root of 1 minus that cosine of angle u, that original angle is 3/5 over 2. 1 is the same as 5 over 5, so let's write this as the square root of 5 over 5 minus 3 over 5 is 2 over 5 over 2, which equals the square root of 2 over 10, or the square root of 1/5. Which, if you take the square root of the top and bottom, you get 1 over the square root of 5, which you can write as square root of 5 over 5. Now, cosine. Instead of drawing those right triangles, the previous one it worked well because we had a 3, 4, 5 right triangle. In this case, I'm going to use the formula. The formula says this is going to be plus or minus 1 plus the cosine of u over 2, which is like 1 plus 3/5 over 2, which, thinking of this as 5 over 5, is going to give me 8/5 over 2, which is like the square root of 8/10, or the square root of 4/5, which equals 2 over the square root of 5, or 2 root 5 over 5. Now, tangent is always the easiest one, because tangent you can take your answer for sine over your answer for cosine. And since you have over 5 on both top and bottom, in fact, square root of 5 on both top and bottom, this whole thing simplifies to 1 on top and 2 on the bottom. So the tangent of that new angle would be 1 over 2. All right, ladies and gentlemen, that wraps up our notes for this unit. So take care of this homework here, get some practice on these kinds of problems, and that should wrap up this entire unit, the entire Chapter 5 on trigonometry.